Yes, so I will talk about this KickJS engine. But what I really want to talk about is how we use a game engine or a WebGL abstraction to reduce the complexity when programming WebGL stuff. So let me shortly introduce myself. I'm currently working as a PhD student at the Technical University of Denmark. The reason why I'm standing here today is that I wrote a master thesis using a WebGL where I created this KickJS engine, which was finished, or the master thesis was finished this March. So the agenda for today is I'll give a very short introduction to KickJS and then explain all about why WebGL is actually bad for you. So as I said, KickJS is a JavaScript engine. There actually exist a number of alternatives to engines like FreeJS, but FreeJS is the most developed JavaScript engines. KickJS is available on GitHub as an open source project. And KickJS has a lot of the same features as FreeJS. So basically it just adds a level of abstraction to the WebGL part. So most importantly, it adds a scene graph and it handles loading of 3D models into the browser. So I think we all agree that WebGL is great. I hope you are familiar with these applications. Otherwise, you should check them out. I'll not show them to you. First, we have Roam, which is a music video or interactive music video. Then we have some raycasting or ray tracing from Evan Valence. And finally, Google Maps have created this fun little game called Cube, where you control a ball on a 3D cube. But even though WebGL is great, it brings a lot of capabilities to the web browser. There are some bad things about WebGL as well. So I basically have 3 things I think that works very bad with WebGL. The first part is that it's way too low level, at least for JavaScript developers. JavaScript developers tend to work at a fairly high level of abstraction, whereas WebGL is very low level. Also, the API is based on a C API, the OpenGL ES2. And this brings a lot of new complexities to JavaScript, which JavaScript developers are not familiar with. And finally, we want to, or we need to write very high performance code, and this can be fairly tricky in JavaScript. And I would give some examples that shows that it's in some cases more difficult than writing C++ code. So, first claim, JavaScript is too low level. So if you want to learn JavaScript, where should you go? I would recommend this fantastic website called learningwebgl.com. Oh yeah, if you want to learn WebGL. This basically gives you a very good introduction to WebGL and how to program WebGL. But at the same time, it also you very soon realize that it's not that easy to get started with WebGL. So the first example from learningwebgl.com renders these two objects on a black background. And for this, you need this amount of code. You need 132 lines of code for rendering these two simple geometric figures. And of this, there are no comments in this code. And that's actually not enough. Besides this code, you also need a library for handling some 3D math that is not included in this code. So in reality, you need more than this code to just create this very, very simple thing. So what I'm saying is that when you are when you want to create some web application using WebGL, you should consider if JavaScript is the right abstraction level for you. So the KickJS, if you want to create the same, you would write some code like this. This is 29 lines of code and additional 5 lines of comments. And of course, it has one dependency, that is the KickJS library. So the WebGL API, as I told you, it's based on OpenGL 2. The library is actually just one class because it mimics the C class, the C functions. So it has 135 methods and nearly 300 lines of enums, which is constants. There's absolutely no abstractions. It's very low level. There are no modularity. A JavaScript developer usually expects to find a few classes and stuff like that, but here it's basically just one class that contains nearly everything. There are no data structures. This means that you work with blocks of memory. But of course, it performs well, and that's the reason why we use it. Other problems with WebGL is that error handling. JavaScript developers are used to, whenever an error occurs, an exception is raised. However, that's not the way OpenGL ES works. So whenever an error occurs, nothing happens. So to check if an error has occurred, you need to call a function to see if everything's okay. So this is fairly annoying to use. Fortunately, there is some clever guys at Kronos who wrote this wrapper function that you are able to, in kind of a debug mode, get errors anyway. Another problem with WebGL is that, as I pointed out before, that you basically just work with one major class with a lot of functions. So the way you handle references, you do that by handles. And what does that mean? What is a handle compared to an object? The difference is that handles are not garbage collected. This means you suddenly have some kind of JavaScript code, and JavaScript developers are used to working with garbage collected objects. Suddenly, they have something different. Suddenly they both need to allocate and deallocate objects themselves, which is tricky. Now let's talk a bit about JavaScript performance. I have this very simple function here. I'm not sure that you can see it, but it's basically a reflect function written in C++. I assume that this function or this code knows some kind of 3D class. So the reflect function can be written like this. So basically you have an incoming vector and a normal vector, and you want to calculate the reflection vector. So in C++, it's almost pretty. So next thing, we have this naive JavaScript translations of the function. And already here, even though it's nearly as neat as the C++, we see actually there are some differences. And one difference is that there are no operator overloads. This means that instead of this minus up here, and instead of this multiplication, you would need to invoke some methods. But that's okay. I mean, it doesn't make it that horrible. It could be worse. And actually it is. If we take this function and then trying to write it on 4 lines, it's the same function, it just tries to explain what happens. Now the first 2 parts, I calculate the dot product and multiply the dot product by 2. This is all fine. This allocates basically 2 numbers. Now the next thing is that we have a vector that we scales with a constant, a number. That creates a new vector. And the final thing is that we subtract one vector from the other, which also create a new vector. This means that for this simple JavaScript functions, we create 2 new objects. This was not the case in C++. And why is this bad? Well, we don't want to create objects. Objects become garbage, and garbage needs to be garbage collected. And this means that if this reflect function runs inside the rendering loop, we would get some garbage collection interruptions. So we would not get a smooth animation. Fortunately, we can solve this. What we do is we introduce a optional input parameter, this res, which we pass on to all the objects or all the functions, and then we don't have any garbage collection. But if we take a look at this C++ function and this JavaScript function, then I mean, JavaScript developers usually think that their language is simple and beautiful, whereas C++ language is very complicated. But in this case, it's the other way around. C++ is very simple, beautiful. JavaScript is messy. One thing to note is that this is how JavaScript engines works today. A lot of things are going on to improve these JavaScript engines. So it could be that within a year, within a couple of years, we could go back to the first simple naive implementation in JavaScript, and then the engine would simply optimize it away. But the way the world works today, or the engine works today, we have a problem, and we need to write this fairly complicated code for achieving high performance. Another issues. Now, this is actually something, if you want to write high performance code in general, you would need to take a look of data-oriented design. Data-oriented design means that we need to structure data in a way that the CPU or GPU likes. The problem with modern computers is that the CPU and the GPU has become incredibly fast, whereas the memory of the computer is not as fast. So one solution is that we have added a second level cache a third level cache for the computer. But basically, if you want to process huge amount of data, you really need to structure the data in a way that the CPU likes, and that way is simply just sequential. This is true both for JavaScript and for C++ and any language. A good example of this is how to structure mesh data. So this basically shows two ways of structuring a mesh data. You could have multiple buffers, one buffer with all the vertex data, one buffer with the normals, and one buffer with the UVs. But the GPU actually prefers this interleaved buffer, where for each vertex you have a position, a normal, and a UV mixed together. Then it basically just can go from one end of the data to the end of the data. Now, in JavaScript, the problem with doing this is that it's not always possible to use this data-oriented design. The problem is that in JavaScript, objects are allocated on the heap. So this means that whenever you have an object, you cannot really tell JavaScript where to allocate this object. It's basically just allocated somewhere in the heap. And when working with WebGL, you also have these things that some of the WebGL handles are actually objects, which makes it impossible for a very efficient structure of data-oriented design. So, the conclusion. I think whenever you are to write a WebGL application, you should use some kind of abstraction layer. This could be KickJS, or this could be FreeJS, or anything, or maybe you could write your own. But I think that's where you should go. In other words, you should not use a architecture like this, but use some kind of abstraction where your application does not talk to WebGL directly. Yeah, so now the big question is, what kind of abstraction layer? Yeah, that's basically for you to find out. That's a whole other topic for another talk. But tomorrow I'll give a workshop of how to use KickJS. I think it's fairly similar to FreeJS, but I'm not a FreeJS expert. So that was my talk.
We have little time for some questions. Are there?
You talked a lot about the problem with memory management and real-time code, and something that's been bothering me too. Have you ever tried Star.js or Heap Coffee?
No.
So I recently read about them. Probably check them out. They're basically meant to be statically typed JavaScript and CoffeeScript, and they compiled down to a stack architecture. They don't pass by reference. They always pass by stack stuff. Sounds good.
Yeah, but I mean, the JavaScript environment, even though you implement a stack on that, it's basically still allocate object in the heap.
No, it doesn't. What they do is basically you make a structure definition like a C struct, and they translate the code to indexing into arrays, all the code. So if you access any structure, you don't have actually a structure object. It recomputes the pointer you meant to have from the code you wrote. Check it out.
Okay.
JStar Heap Coffee.
I want to ask you a question about are there some websites or knowledge forums where you can test the fast your engine is? Because yeah, you can translate it in milliseconds. So
Yeah.
probably there is some.
I mean, as far as I know, there's no direct benchmark between the JavaScript engines. Are you talking about WebGL engines or JavaScript engines?
No, the WebGL engines.
WebGL engines. Not as far as I know. A thing to note is that it's actually fairly hard to write a benchmark of two engines because they probably are different. So, I mean, if you write a benchmark, then it may be a perfect fit for one engine, but the other engine does something more that is not tested, but
Yeah. Okay.
have some performance penalty.
Okay. Thank you.
We have time for one more question. Okay, the last question.
Okay, why redoing your own or not doing a game engine on top of 3GS?
Well, my yeah, basically because I want to. And also, I think in some cases, 3GS is not the perfect choice. What bothers me most with it is that it has multiple backends, which of course has some costs, I believe. And then I liked writing game engines and thought it would be a good challenge.
Okay, thank you very much, Morten.